As a team of full-time and part-time eyeglasses wearers, we all agree that ophthalmologist visits are expensive, unpredictable, and time-consuming. We go consistently because we have a fear of potentially going blind in the future. And we're not wrong. 80 out of 200 million cases of age macular degeneration are identified in the late stage where treatment options are actually quite limited. However, early identification and intervention can reduce vision loss by up to 50%. We propose to leverage neuromorphic technologies which improve CSLO imaging of retinal pigment epithelium cells. We specifically selected the CSLO retinal imager because it allows for real-time imaging of RPE cells with contrast and works like any traditional imager or telescope using lens, a detector, and a non-invasive laser directed at your eyes. And then it generates these lasers at different angles to your eyes to generate a 3D topological image of your retina. So why did we select RPE cells? Because they are linked to multiple retinal diseases. However, we will be focusing on age-related macular disease, diabetic retinopathy, and the secondary effects of cataracts. Traditional CSLOs and the likes have many disadvantages: light loss and reduced signaling, limited identification of optical aberrations. They're bulky, importable, and complex, and have image degradation due to noise and out-of-focused light. So we at Retino promise to sharpen vision and revolutionize diagnostics related to your retina. So we use neuromorphic computers that enhance adaptive optics. So in a normal eye setting, the neurocomputers will sense any changes in the ones and zeros and capture a more accurate image of your retina. But let's say we have an optical aberration like an AMD or a cataract. Instead, the computer will send the neuromorphic sensors will change the differential mirrors angles, which are basically the adaptive optics, in order to collect more light at the areas where you have these optical aberrations, building a full picture of your aberrations and sending them instead of reducing the light. So first, our demo works by inputting standard libraries for any deep learning model, and then we use Brian 2 to allow us to do any neuromorphic modeling, and it simulates how the computer can process visual information in the same way that we respond to stimuli. In the first cell, what happens is that this is where pre-processing occurs, and the pre-processing model converts and standardizes any image to 224 by 224 images, and it makes sure that it becomes easier for us to actually identify accuracies later on and observe the images. So this is it being standardized. In the next cell, the detect events function, what it allows us to do is that it allows us to look at any neuromorphic events detection, and those are basically any changes in the visual outputs, much like our eyes react to any changes in our environment, and those are called events. So these event detected areas will go and be highlighted by this function, and this is really important for key disease detection of either the glaucoma or the AGD, the AMD. And then here is how we simulate any adaptive optics. So that is using advanced parameters like the Gaussian blur, which smooths the image, and the sharpening filter, which allows us to remove any noise and marks any regions with events that were found in this cell. And after that, so it shows any signs of disease for glaucoma or diabetic retinopathy, and this is how it looks like with the enhanced adaptive optics feature. Then in this one is where we look at the spike neural networks model, and this model helps us to classify these retinal images, so from the normal eyes and the retinopathy and the glaucoma and cataract. And basically we use 3 SNNs followed by these layers, as you can see here, using keras, and these capture any features in spatial features. And then this minimized the error during training using a famously known atom optimizer, and those work together to give us these accuracy models over here. So basically, in this cell as well, we can use real-time disease classification over here, and it uses the trained model to predict from a new retinal image based on the features that it identified previously. And this also works to compare how the normal versus the identified images look like together, and that's the final retinal image with neuromorphic feedback being altered. And we successfully proved an 86% accuracy. So, we at Retino promise to protect your long-term vision accurately, eliminate your fear of potential vision loss in the future,
while detecting any early changes in your morphology of your eye. Thank you.